In this video, I'm going to be talking about how to solve a compound circuit problem. At this point, you've probably solved for a series circuit problem and a parallel circuit problem individually. So you want to make sure you're pretty confident in understanding the concepts and how to do the calculations for both of those two types of circuits before moving on to a compound circuit. So a compound circuit is basically a circuit that has a bunch of parallel and series circuit properties within it. If I'm taking a look at this circuit right here, the charges are going to be leaving the power source, going through the 6 ohm resistor, breaking up into two branches, and then coming back together to go back through the power source. So the best way to approach these problems is to condense your resistors as much as possible and simplify the look of your circuit, and then from there start to solve for values from there. So the first thing I'm going to notice is that this 12 ohm resistor and 8 ohm resistor are in a little series circuit together, so I can go ahead and represent those as a 20 ohm resistor, and then I'm going to redraw the circuit to look like this. So I went ahead and combined those two resistors and I made it look like a 20 ohm resistor. So what I'm going to do is I'm going to continue on until I can condense my circuit down to look like a series circuit. So I see this little parallel circuit within my compound circuit with a 5 ohm resistor in one branch and a 20 ohm resistor in another branch. So what I'm going to do is I'm going to go ahead and take those two resistors and combine that into a single resistor. So what I did is I added up the inverses of each of my resistors, and I got 1 over 5 plus 1 over 20 equals 1 over RT. And then the lowest common denominator was 20, so I added those up by hand. I got 5 over 20 equals 1 over RT. Cross multiplied the numbers, so the RT flipped over here. The 1 dropped below it, which I don't really need. And I had the 20 drop, go up this way, and the 5 drop underneath it. So 20 divided by 5 is 4 ohms total for this parallel circuit chunk. So I'm going to go ahead and redraw that circuit one more time. Now I've simplified the look of the circuit as much as I possibly can. I could actually simplify it down one more time and combine these two, but I don't think that's actually necessary. Now what I'm going to do is I'm going to find the total current that flows throughout the circuit, and I'm going to use that current to help me solve for the rest of the values, so I can also solve for the voltage drops through each of the individual resistors. So I went ahead and found the total resistance by summing up my 6 ohm and 4 ohm resistor to get a total resistance of 10 ohms. And then I used Ohm's law by taking V equals I times R, rearranging it so I equals V over R. And I took my total of 20 volts divided by my total resistance of 10, and 20 divided by 10 gives me a total of 2 amps. So in a series circuit, that means the total amount of current everywhere in the circuit is 2 amps. So the amount of current leaving the power source, the amount of current flowing through the 6 ohm resistor, the 4 ohm resistor, and then back. Now, if I go back to my original circuit, we do have 2 amps of current flowing out of the power source. We do have 2 amps of current flowing through the 6 ohm resistor. But now if we take a look at what the original circuit looks like, we know that it breaks up into 2 different branches. So what we need to do is we need to find the V and the R for each of the different branches, so we're able to find out how much of this 2 amps of current splits up into each branch. So far I know that the current that flows through each of the branches is going to be less than 2, but some up to 2, but I don't know the exact value just yet. So what I'm going to do is I'm going to use this diagram over here, and I know that the voltage drop is equal to I times R. And I know that 2 amps of current is going to flow through this whole entire section over here. And I know this whole entire section looks like a 4 ohm resistor. So I'm going to take 2 amps times 4 ohms. And then get 8 volts. So I know that the total voltage drop through this section is going to be 8 volts. Okay, I can do the same for this portion over here. I can do V equals I times R, and then find the voltage drop through the 6 ohm resistor. So now that I'm taking a look at each of these branches separately, the way a parallel circuit works is each branch receives the same amount of total voltage drop, and that turns out to be 8 volts. So I'm going to have a delta V of 8 volts through this branch, and then I'm going to have a delta V of 8 volts through the second branch. And now from there, I'm able to solve for the amount of current that flows through each of those sections. The way I'm going to do that is just use Ohm's law again. And remember, if we want to find current, current equals V over R. So what I can go ahead and do is I can take V over R, 8 volts, divided by 5 ohms. And that will tell me my current is 1.6 amps flowing through this portion of the circuit. And then on this part of the parallel circuit, we have a total of 20 ohms resistance for this entire branch. So we can take 8 volts divided by 20 ohms, and that gives us a total, or a value, of 0.4 amps. So now we have our 2 values for current, 1.6 and 0.4, which do sum up to that total of 2 amps. And then once they merge back together again, going back into the power source, we have a total of 2 amps of current. So now we have the voltage drop, the current, and the voltage drop and the current through each of the different resistors. So what we did was we condensed the look of this little series circuit, condensed the look of this parallel circuit until it simplifies the circuit to look like a simple series circuit. And then from there, we found values for the current so that we can go back and then look at the little intricate parts of the compound circuit and then solve for the voltage drops and currents through every part of this compound circuit I hope that was helpful in helping you understand a compound circuit problem. Thank you for watching and listening.